Welcome back to the Byte Attic for some bonus material on this episode about the ZX-81. In the previous 3 parts you've seen me restore this little thing, restore to a unheard of extent. It's much better than new, but I have a surprise now, because this deserves a very special treatment. It was my very first computer, so here is another restored ZX that I didn't shoot footage of. The case has been restored by my girlfriend in exactly the same way, so they are very much identical. It also has a brand new keyboard. I'll set this aside for a moment. I'll set the case aside for a moment, and I want to show you the board. In fact, I have worked on this before the ZX-81 you saw in the previous 3 parts. And this work started as a little repair. I diagnosed some broken traces, so I installed 3 bodge wires, which you can see here underneath the protective Kapton tape. It was a simple diagnosis and repair, and then I had the thing open in my hands, and then I started doing stuff. And I've done everything on this that you saw me do on this one here. Sort of got out of hand. The memory upgrade is the same, except that I hadn't realized yet that by closing link 2 on the PCB here, I didn't really need to lift this pin. So I have 5 lifted pins instead of 4, and indeed I connected them to the upper side of the board, because the missing address lines on this issue 1 of the ZX-81 board were on the top side, and in issue 3, which is the one you saw me work on, they were on the bottom side here. So, they were on the bottom side. So I could use empty pads instead of reusing pads for the diodes here. And yeah, the processor is also a new CMOS. This is 16 kilobytes of addressable onboard RAM. The ULA is an old one, week 32 of 1981, but it does work. I also put gold-plated 3.5mm jacks in here. Someone asked me after part 3 why I used this nut in here, since you can't put the jack, the nuts on the outside of the board. They stay inside anyway, so why use these nuts? And the reason is, if you look with attention here, I hope it's in focus, the nut, if you install it correctly, will overlap with the edge of the PCB. So when you push a plug in here, the mechanical force, the mechanical pressure you apply will be taken by the nut against the edge of the board instead of by the solder joints. That's why I installed these nuts in there, both this board and the other one. It's also recapped. It also has a composite video modification, which was not as good as the one I did here. Here I got the values of the resistors right. In this I hadn't, but now I changed it according to what I did here. So now it's a pretty good mod as well. I even changed the resistors that you can see here. The previous ones were working, but they were installed in a very funny way. The leads were way too long and they formed little loops. Let me see if I can still find one with that. No, I changed them all. And those loops and the length of the leads would just increase the parasitics, the inductive and the capacitive parasitics, too much. And on a data bus that already suffers from malformed signals because of this resistor splitter, this resistor bank that splits the data bus, as we talked about in previous parts, I thought, I would just correct it, and I installed new ones with shorter leads and straight leads instead of forming little loops. So there are a couple of things I now want to take the opportunity and do on this board, mainly to illustrate things for you. One of them is this little device here, which is VLA81. This is a modern replacement for the ZX-81 ULA. It has been designed by a smart guy out of New Zealand. And it uses, I believe, either an FPGA or a CPLD, but in any case, a modern version of a gate array, which you can program even at home. You don't need to program that in the metal layers. Here it is. It is a Xilinx, and I believe it's a little CPLD, although I don't recall the part numbers off the top of my head. But yeah, this is much smaller. As you see here, the packaging is much smaller than the original, but it has the same function, and it adds some functions. For instance, you can use one of the pins here that on the original ULA gets the signal from the ceramic oscillator in order to generate the clock. This one can generate the clock internally. I think it has a little crystal here. So you can use that pin to address 32 kilobytes of onboard memory instead of 16. I, however, will not do that little modification because most of the software is for 16 kilobytes anyway, if not all. And I'm not going to program relatively large pieces of software for the ZX-81. Serious programming I would do in other machines. So I will replace the old ULA with this one to prove it to myself that this does work. And if it does, I'll just leave it there, and I will keep the old ULA, which is a historical part from 1981. I will keep it in my safe stash of historical parts. And then after I've done that, there will be only the ROM that is original on this board, and the PCB itself. And there are modern replacements for the ZX-81 ROMs, but I do not recommend them. The problem I have with that is that these things are made with flash memory, which is the same kind of memory that you have in today's USB sticks, thumb drives, SSDs, the solid-state drives that you get on Apple computers now. My Apple computers all have SSDs and not normal hard disk drives. So the memory is good, but there is an issue with the retention time. Flash memory is not made to retain its contents without being refreshed every few days or at least every couple of weeks, which is what the firmware in SSDs does. The firmware on my iMac is constantly looking at bits that haven't been rewritten in a while, then it moves them around to rewrite them and refresh the contents. Otherwise, if you don't do that, and this little old computer has no firmware to refresh the contents of flash memory, they will be lost. If you are lucky, it could take 10 years. If you are unlucky, it could take only weeks. If the objective is to have a computer that will be functional for the long run for another 40 years, this computer is already 40 years old, then you don't do that replacement with a flash memory. So I'm going to replace only the ULA. Let's get to it. Yes. Here is our second ZX-81 with the VLA-81 ready for testing, and I checked this ROM. This is a mask programmable ROM, so it's going to last for a very long time. Still, it may fail for the reasons, but it's not going to lose its contents because they are etched into the metal layers of the chip, unlike a flash memory in which the contents are stored electrically. Okay, let's turn it on and see what happens. And there's the cursor, so it seems to work. I'm going to put it back together now. can use your computer or your iPod, your phone, to play sound files to your ZX-81 in order to upload software into it, to upload games and applications. To do that, you will need a utility to convert the original ZX81.p files that you see in here into .wav files, or WAV files that your computer, iPod, or phone can play for the ZX81. You need a utility to make that conversion. I recommend you go to zx81stuff.org.uk and do a search for tape utilities in there, and you will find a Java application that performs this conversion. You can download it here. It's a .jar file. There you go, it's on my downloads folder. I'll put it in here on my desktop. And you need to have a Java development environment installed that can execute this .jar file. If you don't have it, the computer will guide you to install. On a Mac, if you just try to open it, it will complain that there is no identified developer, so you cannot open it, but we can force it to open. Yes, open. And now, let me see. So you need to have a Java development kit. So we just will install one. Java EDK download. Quick search. We go to Oracle. Yeah, accept all cookies. JDK download. In my case, I will go for a Mac OS installer, because this is a Mac. So just download it. Allow it to run. It is still download here. You can see the progress bar. I'm going through all these steps to at least give you an example, a complete example of how to go about it. Takes a little while, even with a very good internet connection. Okay, go back to downloads and open the DMG file. I will iconize these now. Yep, it is installed. We move the installer file to trash, and now should be able to just open the tape utils. And there it is. Now, we need a .p file to convert to a WAV file. So we have to go back to the web. And now I will recommend you go to another website called RWAP software, and just do a search on this, and it will be the first hit in there. And then we'll go and look for ZX-81 software. There we go. There is a number of possibilities here. Chopper drop is very nice. I'm going to download version 1. Allow. So there we go again. There is a .p file in there. So now if everything went all right, you have your .p file with a game or an application, chopper drop in this case, and you have your tape utils.jar. So we open that application, I'll centralize it, and then from there we open the .p file that we've just downloaded. Let's open it, and then it will do a quick analysis. The important thing is that it says no errors, no warnings, so we can just close this window, and now we will save it as a WAV file in another directory. And I'll put it in the desktop. So we just save it. And here It is. So now, if I play this file, this is what you will hear. Yeah, so that's what you can play to the ZX-81 from your laptop or your phone or your iPod, whatever, and that's what we are going to do now. Okay, two fully refurbished ZEs. I'll be using this one. I actually don't remember which of the two this is, the one you saw me refurbishing or the one I did without filming. Doesn't matter, let's just turn this one on. There it is. Takes a little while for the cursor because it has to recognize the full onboard 16 kilobytes. Here's what I will be doing. I'll be using my little MacBook Air. I will be playing the WAV file you just saw me create. So this is the Chopper Drop 3000.wave. I'm directing the sound output to this USB device here, which is basically a splitter. It has an earphone and a mic output. The volume I'm setting for 3/4, and then the ear output goes into the ear connector of the ZE. You might think, well, the ear output of the computer should go into the mic input of the ZE. But Sinclair figured out that consumers don't think like engineers. Consumers would just try to match label to label. So if it's ear here, it should be ear here as well. So you have to connect ear to ear, mic to mic. I am using a mono 3.5mm cable. That's how it looks like. It only has two polarities. You can, in principle, you can use a stereo one, which I have lying here. This has 3, so 2 channels and a common ground. If you do use the stereo though, you have to go to the balance control here and put it all to the right, which is the tip of the stereo plug. I am using mono, so it doesn't matter. So what we have to do is to type a little command on the ZE, load, and then like this, and then we press return, and what it will do is whatever signal is in here, it goes straight to the video output. So you see that crazy thing. The TV may lose synchronization as well now and then, because this will not have a back port, it will not have the synchronization pulses. It's just a extremely cheap way, actually free, to give you feedback about what's going on the input here. And then once it's loading, we just play the WAV file here. And you see the TV already lost synchronization. Hopefully to catch some synchronization again now and then. But this is a 16 kilobyte game, so it will take about 6 minutes. 20 seconds to go. No feedback on the television, it just doesn't sync. But we can see here that the sound is being played. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now we should see something. And there we go. Flawlessly uploaded. This little gold-plated 3.5mm jacks here really do the job. They will never oxidize. They're very good. So let's see if I can still play this thing. Q and A is up and down, O and P sideways, and M for fire. It's a pretty difficult game if I remember. Lost synchronization. Here's the problem. When I installed the VLA-81, I forgot to flip the very first dip switch on top to on. Without that switch flipped to on, the ULA replacement will not produce synchronization information. And as a matter of fact, this is precisely why the image had such a good contrast, as you can see in this comparison. To the left, you see the image without synchronization information. and to the right the one with proper synchronization information. And the reason for this is that without the synchronization information, there are only two levels on the video signal, which the TV will interpret as white and black and will stretch them to the extremes, giving you excellent contrast. But once you add the synchronization pulses, there will be three levels in the TV signal, the lowest of which the TV will interpret as synchronization, and then it will know correctly when the frame is starting, and we will not have the problem that you've just seen. However, the other two levels, corresponding to black and white, will be closer together, and there will be a little less contrast. The black will look more like a dark gray as opposed to black. This one has taken only about 3.5 minutes, you can see here. So it must be an 8 kilobyte program. UFO, based on the 1970s series. I remember the series. I was a young kid, a toddler, but I remember it. Okay, how am I gonna play this? 6 and 7 is up and down, and 8 is fire. That's kind of simple. Let's see. Interceptor ready. That's supposed to be the explosion, I guess. Oh! I got busted. Red alert. You gotta have a lot of imagination. Because these programs are so simple, they leave everything to the imagination. The thing is, as a 6-7-year-old kid, I could understand how to program these things. I knew how they worked because, all the graphic characters used are right here on the keyboard in front of you. So I could wrap my little child head around how to program this. And that's what made it so special. I wasn't just a player. Every time I played a game like this, I could fathom what was happening. And that's unique for this machine. Children today play with their iPads and iPhones and whatnot, and they have not the faintest idea how it's done. And I could play a game like this, and then afterwards sit for an afternoon and program something not as good, but something vaguely similar. It was possible. It was an achievable goal, and then it played a huge role in my life. Games as education was not just an ideal back in the day. I literally got educated largely from playing games, because I would just try to reverse engineer the games, or I would get ideas to build something which I thought would be better and program my own game in a better way. That was real education, computer science education. In a world like today, dominated by computers, it is very important for kids to have an idea how this stuff works. Otherwise, it's like magic. And then you get all this bullshit about conscious computers and uploading and downloading your consciousness and all that nonsense. That nonsense gets airtime today because people have no idea anymore how this stuff works. And if they have no idea, it becomes magic, and then everything is plausible. All the nonsense becomes plausible. Now brace yourselves for the most well-known, or should it be the best-known ZX-81 game, a myth of the 80s, an original from back in the day. Guess what?